Hello and thank you for watching this video on triangle midsegments. In this video I'm going to go over triangle midsegments theorem, go over the triangle midsegment theorem to find segment lengths and solve equations. Let's start with the definition of the triangle midsegment. When the line segment that connects the midpoint of two sides of a triangle and is parallel to the third side, what basically this means that if I have, again, you see these two sides here, if I find the middle point on the segment on the side on the right, left on the triangle, and I find the middle point on this right side on the triangle and connect them together, this right here is called the mid segment. Now, several things that can occur in this situation. First, these two sides are going to be congruent. These two segments right here are going to be congruent, and these two segments here are going to be congruent. Now, because this line here is parallel to this line, okay, if I extend it, what we end up seeing again is two transversals. So we have a set of corresponding angles. So these two angles here are congruent, just like these two angles here are congruent. So we end up creating again two sets of congruent angles. And lastly is that since this is exactly in the middle and it's parallel to this, the length of the mid segment is equal to half of whatever length this is right there. So in other words, like this from point to point would be halfway to this bottom side here, and thus if I put another one of those, I end up going from one corner to another corner of the triangle. So these two parallel sides can be equal to each other if I do one of two things. I either divide this by 2 or I multiply this by 2. So let's look at again that situation on a triangle that's labeled, and let's discuss again what I just and let's label and discuss again and identify the things we just spoke about. So let's start off with the angle. So like I mentioned earlier, these two angles here, this angle D and this angle at the vertex A, are going to be congruent. So angle A is congruent to angle D, which again means that they are going to, the measurement of each of these two things are going to be equal to each other. And then these two angles here on the right are also going to be congruent. So these two angles are congruent. So angle E is congruent to angle C. And then obviously, as you can see, the segments are congruent. Segment AD is congruent to segment DB. And then these two segments are also congruent. So the segment from B to E is congruent to the segment E to C. And finally, the relationship between the mid segment and in this case the base of this triangle here is that, which is probably the most important of all of these things, is what we use mostly a lot, is that the length of DE, the distance from D to E, is equal to 1/2 the distance from A to C, or we can say AC is equal to 2 times DE, which in this situation is probably easier to use this one when we're trying to set up and solve equations. So you'll see this one is very, very helpful for equations. So very useful for equations. So let's look at an example where we just have numbers. And again, the idea is, again, if I just find again the midpoint between any, so let's say I find the middle for, let me erase all of this here, and let's say I find the middle between A and C. So let's say I find this middle right here between A and C, probably a little bit over more. Okay, I find the middle right there, and I connect, since I already know that D is in the middle, and I connect the point D to this middle point right there. Well, this line here again is going to be parallel to this line there. So the same thing again that is true, the same fact about DE and AC is now going to be true about this blue diagonal line and this blue diagonal line. That the distance from here to here, let's call that point F, the distance from D to D to F is going to equal to half of the distance from B to C. So it's going to be again the same fact about that. And since I have already the middle point F, if I connect that middle point F to point E, as you see right here, then this side, again, which should be parallel, I know it doesn't look like it's parallel, it doesn't look like it's slanted the same way, but had I done a better job and actually found the middle, you would see that they would look parallel to each other. And then the fact about, again, DE and AC is also going to be true about these two green lines, that the distance from E to F is going to equal to half of whatever the distance is between A and B, or vice versa, that the distance from A to B is going to equal to twice whatever this number is right there. So let's look at an example of this situation. So as you see right here, again, let's start by identifying and telling us again, they'll tell us here that these points are in the middle. As it says right there, they're midpoints. So having these midpoints and connecting them with straight lines creates them as mid-segments. So if I label and I plot the points for 46 is this distance right here, so that's going to be 46. The distance of PQ, which is this distance right here, that's equal to 40. And then the distance from L to N, which is this one right here, that's going to equal to 17. There, that looks more better. I can identify again the three missing sides that they want, starting off with LM. So with LM, so that connects L to M, that one right there. Let me do it in blue, because this is parallel to that blue line that I wrote originally from P to R. So since P to R is parallel to this line right here, and again I know it's parallel because it's not intersecting, again that means that this distance is twice as long as this distance up here. So if I divide this number by 2, I end up with 23. So that's the length of that right there. That's going to equal to a total length of 23. And again, I can kind of prove it here. Let's see if I can move this. Not the way I wanted to move it. Let's see, let me try it again. Let's see, there we go. So you see, look, if I move this over, notice that it reaches barely, or it reaches exactly halfway. And if I move it over to the other side, again it reaches to the other half. So again, just a little proof that the distance from L to M is half the distance from P to R. So I end up again getting a total of 23. Let's look at the next one. So again, let me label this as 23. M to N. M to N, that is parallel to the red side of 40. So these two sides are parallel, which means that 40 is twice the distance from L to M. So if I divide 40 by 2, I get 20. So this measurement is 20. And then finally, from Q to R. Well, the distance from Q to R, that's twice the distance it is from L, here it is, L to N. So since L to N is 17, multiplying that by 2 gives me 34. So the measurement here is going to be 34. And they also ask us to figure out the distance from M to R. Well, M to R, which is that distance right here. Let me get my yellow highlighter. This one right here. This m to r. Well, that's again the same distance as L to n, because we're going halfway right there. Notice again they're the exact same length. So that's going to equal to 17, which again is exactly true just by looking at this. Since this entire distance is 34, then dividing, since m is in the middle, that means that these two segments are equal. So if I get 34 and I divide it by 2, I get 17. So I know this is 17 and that is 17. So the distance from m to r is going to equal to 17. Let's look at the next example. Here again, similar situation. If I again label the points that we have, we know that F, G, and H are midpoints to the side of the triangle CDE, and we're told that the distance from F to G is equal to 9. The distance from G to H is equal to 7, and the distance from C to D, which is this distance over here, that's equal to a total of 24. So let's start by finding the measurement of CE. Well, CE is this distance down here, which is parallel to this red side of 7. So let me color coordinate this. So using 7, we know that this distance right here would have to be 14. The distance from D to E is this distance right here, which is again parallel to this blue side. So color coordinating this with the parallel side of 9. Again, 9 is half of the distance from D to E. So multiply 9 by 2, 18, gives us the distance from D to E. And then finally, the last thing is F to H. So that's this distance right here, which again is parallel to this side right here of 24. So since these two sides, again, this is the mid segment of this triangle here. So this side, again, that's parallel to this side, is going to be half the distance. So that's going to be a total of 12. So the distance here is equal to 12 units. And now we have the perimeter. To identify the perimeter of this triangle, we're simply going to add up the three sides. We're going to add up 24 with 14 and 18, because again, we want the perimeter of CDE. So using points C, D, and E, again, that's this triangle here. What's the total distance to go around that? We would add again these three numbers. So adding 4, 4, and 6. Sorry, that's an 8. Let me write this neater. So we're adding 24 with 14 and 18. This is equal to 16. Carry the 1. 56. So that's the perimeter of this triangle. 56 units. So moving on to our third example, let's see how we can use this idea, this mid-segment idea, to set up equations. Well, on this example, we want to just simply figure out the value of x, and since we're given the mid-segment length of 7x and the parallel side, this third side, which is parallel to this mid-segment at 17x minus 18, well, the relationship between these two, in order for these two things to be equal to each other, is, well, this is half the distance of this longer side. So the only way that these two things can ever be equal to each other is if I multiply this by 2, or the other option is if I divide this by 2. Like I said, when it comes to solving equations, it's easier just to simply multiply something by 2. So that's exactly what I'm going to do. I'm going to multiply this by 2, and as a result, it's going to equal again to its parallel side of 17x minus 18. So we have 14x is equal to 17x minus 18. And then solving this equation using, again, letters to the left and numbers to the right, we would move the 17 over, make it negative 17. And we have negative 3x is equal to negative 18. Then dividing by negative 3, x is equal to 6. So that is the solution to this equation. Another application to this is not just only solving this equation, but then using the solution and substituting in again to one of the side lengths. Like here, we want to identify the length of DE. So we want to know how long this is. Well, in order to do this, we need to know again our value for x. Well, the relationship between the mid segment and this third parallel side to the side it's going to be parallel to is that, well, again, like I said before, this length right here is twice the distance of this bottom length right there. So I need to multiply this by 2 in order to equal it to that there, which again I'm going to do. I'm going to multiply that by 2, and as a result it's going to equal to this longer side. Well, to multiply in this example by 2, I would have to distribute, so we would end up with 8x plus 2 is equal to 11x minus 25. So with letters to the left and numbers to the right, let me bring that down. We would move the 11 to the left side, move the positive 2 to the right side, and we would subtract 11 and subtract 2. Negative 3x would equal to negative 27. We divide by negative 3, and the value of x is equal to 9. So we now know what the value of x is, but since at the very beginning, like I mentioned, we want to figure out the distance of DE, I now plug that in again into the distance of D to E. Well, the distance to D to E is 4 times this value of x plus 1. Not 8x plus 2, but 4x plus 1. I just had to multiply it by 2 in order to equal it to that, in order to equal it to the distance from A to B. But since I want to evaluate and figure out, okay, what's the actual distance from point D to point E, point D to point E, I'm going to replace the x in 4x plus 9 and 4x plus 1 with 9. So we end up with 4 times 9 plus 1, which is a total of 37. So that's your solution. Now, if we want again a little bit more work, the only way to make this more complicated is to add more steps and do more things with the solutions that we find. Here we want to find the perimeter of JKL. So in order to get the perimeter of JKL, we need to add up the 3 sides around the triangle. So looking at the mid segments, we have 3 mid segments here. I can figure out the length of its parallel side by multiplying the mid segment by 2. So like for example right here, we know that this mid segment is 49, so that means that the parallel side would be twice as big. So 49 times 2, that's equal to a total of 98. And the same thing here with this side. Since 42 is the mid segment, its parallel side, which is this side right here, would be twice as big. So multiplying 42 by 2, that's equal to 84. Now the only thing that I'm missing in order to add up with 98 and 84 so I could figure out the perimeter is this third side. And as you see right here, we're not given any numerical value on any end, we're given an expression. So the way that these two things are going to equal to each other is by multiplying this by 2 and setting it equal again to the third parallel side. So to its parallel side, and has to equal to that. So multiplying 6 by 2 and 1 by 2, that's going to be 12x minus 1, and that's going to equal to 13x minus 10. So here let me write this up. So what we're going to have to do in order to figure out the perimeter, again the perimeter of this thing. Now that I know that these two sides are 48 and 90, all right, I would have to do this. First, I need to solve this equation for x. Second, I need to plug that x into this right here, into the 13x minus 10, because I need to know how long this side is. And then thirdly, I need to add again the 3 sides on the triangle, because that's how I get perimeter. So let's see, let's start by solving this equation. So with letters to the left and numbers to the right, we move the 13 to the left side, we move the 1 to the right side, and we're going to get that negative 1x is equal to negative 9. We divide by negative 1 and the value of x is equal to 9. So there, we've done step 1. We've solved for x. We now want to plug in the x into this one right here because we are interested in figuring out the length of this third side here. So plugging in 13 times 9 minus 10, that is going to equal to, let's see, 3 times 9, that's 27. So that's equal to 117, and then subtracting by 10, that's equal to 107. So this side right here is going to end up equaling to a total of, oh no, hold on, I made a mistake with my equation. Again, let's start over with the equation. I did not multiply both of these things by 2. Again, I need to multiply both of these things by 2. So let me fix this and let me write this better so I don't make this mistake. Again, multiplying both of these by 2, I do get that 12x, but I forgot to multiply the 1 by 2, which gives me negative 1. So 13x minus 10. So with now letters to the left and numbers to the right, I get that negative 1x is equal to negative 8, which means that x is equal to 8. So 13 times 8 minus 10 is what I'm going to do. I'm going to plug in this 8 right there, where 13 times 8 is 104, and 104 minus 10 is equal to 94. So the measurement here is 94. So those are the three sides I'm going to add. I'm going to add 84, 94, and 98. So 276 is our perimeter. So our perimeter is 276. Made a big gaffe there, huh? Didn't I? Forgetting to distribute that by 2 again, which is a kind of glad that I did that, because shows again to show it's again a good example to show how forgetting to multiply this, the second number specifically, by 2 again can mess up your equation and end up giving you the wrong solution. So always make sure to again distribute and multiply both of these numbers by 2. It's a very common mistake. As you can see, even I make it. Now for example number 3, here we're focusing now on the angles and what's the relationship between the angles. There are specifically these two angles on the left and these two angles on the right when we have a mid-segment. Now there's nothing to tell us that this is in fact a mid-segment. We have to rely on the diagram, and from the diagram we know that this point is in the middle because these two segments again are congruent. And we know that this point right here is in the middle. Let's call them point D, and I'll call this point E. We know that point E is in the middle because the distance from the top to E is the same distance as from E to the bottom, as indicated again by that little icon right there. So we do have again a mid-segment here because these 2 points are in the middle, are midpoints. So that means again that these angles, angle 2 and angle 1, are congruent, and that angle 4 and angle 59 are congruent. So if the bottom angle is 59, that means that angle 4 is 59. Now, the way we can figure out the measurement of angle 1 and 2 is by using, again, our linear pair. This, let me draw it underneath here, but this here, between 127 and angle 2, is a linear pair. We have these diagonal lines, and we have this horizontal line here, and we have angle 2, and we have 127 in the bottom. Since this, again, are two adjacent angles that make a straight line, a linear pair, then these two angles have to add up to equal to 180 degrees. So adding 127 with whatever this is right there has to give me a total of 180. So if I get 180 and I take away the 127, which is equal to 53, then that would be the measurement of this top angle right there. The measurement of angle 2 is 53. And as a result, since angle 1 is congruent, that is also going to equal to 53. Now the same thing is going to occur again on the right side. Again, we already know that this angle up here is 59. So since this, again, angle 4 and angle 5 are linear pair, 59, and we have this angle down there, again, they add up to equal to a total of 180 degrees. So 59 plus whatever that obtuse angle is has to equal to a total of 180. So again, these two adjacent angles are supplementary. They are a linear pair. So subtracting 180 by 59, we end up with a total of 121. Yes, 121. So the measurement of this angle is 121. Angle 5 is 121. Now the only angle that's missing is angle 3, this angle right there. But since we have all of this, let me erase all of this now. And let me write the two dominant numbers, 53 and 59 there. I can figure out the measurement of this angle here, this top angle here, by using the triangle sum theorem, that all three angles have to add up to 180. So if I get 180 and I take away the 53 and the 59, which is the same as taking away 112, we end up with 68. So we end up with a total of 68 degrees. And similarly, since these angles again are in fact again congruent, again look at EF. EF is the mid segment because E is in the middle because these two are equal to. F is in the middle because these two are equal to each other. Then that means that this angle on EF is congruent to the angle on CB. Those two angles are going to be equal to each other. Therefore, 9x plus 2 is equal to 15x minus 52. So we're going to solve this equation, and since we're figuring out the measurement of CBF, so I'm from point C to point B to point F, we're interested in this angle here. I will plug in the solution for x. So whatever x is equal to here, I'm going to plug it into that x right there because we're looking for the measurement of the angle CBD. So with letters to the left and numbers to the right, I would subtract the 15x and I would subtract 2, and we would end up with negative 6x, and that would equal to negative 54, and dividing by negative 6, the value of x again is 9. This is like the second time we get a solution for x equal to 9. And plugging that measurement, that value, into this x right there, because that's the measurement of angle CBF, 9 times 9 plus 2 is going to equal to a total of 83. So that's your solution. let's look now at our eighth and final example. Now again, as before, as I explained on previous examples, they don't tell us that U and V are mid-segments, but we can tell again, since that U is in the middle, because this segment is equal to this segment as indicated by this, and the same thing on the right side. Those two segments from V, S to V and V to T, are congruent. So U and V is in the middle. And since U and V are in the middle, that means that this angle here on the left are going to be congruent, and this angles on the right, so the one on T and the one on V, are going to be congruent. So they give me the measurement of angle T. The measurement of angle T is equal to x plus 4. However, they do not give me this upper measurement on V. They give me the lower measurement on V, which is not S, which is not this one. They're not giving me this angle. They're giving me this bottom angle right here, which is not congruent. As you can see here, this is an obtuse angle, while this is an acute angle. So these two things are not equal to each other. They happen to be, again, supplementary with the one with 2p, supplementary. So they add up to 180 degrees. So the way I'm going to figure out the measurement of RTV, RTV, from point R to T to V, again, which is this angle, that one right there, I need to solve the value of x. But the relationship between these two angles, like I said, is not congruency. They're not equal to each other. They are supplementary. So I would have to add these two up. I have to add up x plus 4 with 6x plus 1 and set it equal to 180 degrees. So adding the x's, that's going to equal to 7x. Adding the units, the 4 and the 1, that's equal to 5. And that's going to equal to 180. So with letters to the left and numbers to the right, I would subtract the 5, and 7x would equal to 175. And dividing by 7, the value of x is equal to 25. And again, to substituting in that value there, we would get 25 plus 4, which is equal to 29. So that is the measurement of RTV. So 25 plus 4, which is 29, like I said, and that's what we're looking for. The measurement of RTV is going to equal to 29 degrees. So if this one right here is 29, this one up there is also 29. That measurement up there is 29. This measurement right here, that one right there, which is this angle here, this obtuse angle right there, would have to be 151, because 151 plus 29 is equal to 180 degrees. But again, I'm just giving you more information because the question was only asking for RTV, only for that one right there. Well, that concludes again the examples on how to use the mid-segment to solve equations, how to find the side links, again given the mid-segment, and vice versa. Find the side link, how to use the side linked to find the length of the mid-segment. And finally, on these, the relationship between the angles and how which angles are congruent. I hope again this was helpful, and if you haven't subscribed to my YouTube channel, please do so to get again updates and notifications when I upload new videos.